Introduction to Ansible. What is Ansible and why is it useful? Ansible is a tool that helps you automate tasks on your computer or computer systems. Imagine you have a bunch of tasks that you need to do every day, like checking your email, paying your bills, and cleaning your house. You can do these tasks by yourself, but it can be very time-consuming and tedious. Ansible is like a personal assistant that can do these tasks for you, saving you time and effort. To use Ansible, you can do two things. Make a script that's written in a declarative language called YAML, Y-A-M-L. This script is commonly referred to as a playbook, or you can type a single command called an AdHoc command. AdHoc means for this or as needed in Latin. This is a single command that is typically used to check something quickly to perform a quick task, or for the sake of convenience. You can essentially perform this command as needed, hence why it's called an AdHoc command. For a more involved and thought out task or series of tasks that you need to execute, a set of instructions called a playbook must be created. In Ansible, playbooks are written in a simple coding language called YAML, which stands for YAML Ain't Markup Language. Once written in a playbook, these instructions tell Ansible what tasks to perform on which systems. It's called a playbook because each instruction that is written in the script that you'll be running with Ansible may be thought of as a play or a task. So to recap, Ansible is useful because it allows you to automate tasks that you would otherwise have to do manually, saving you time and effort. It is also very easy to use with a simple syntax and a library of pre-written instructions called modules. More on this later. You can use these modules to perform a wide variety of tasks. Additionally, Ansible is agentless. This means you do not need to have Ansible running on any of the machines that you're trying to interact with. Only one machine running Ansible is needed, and this machine would be called your Ansible controller machine, the machine that you have Ansible installed on and running against other remote or even local machines. And just as an additional FYI, sometimes the machine or computer that runs Ansible is also called the control node, or the controller machine, the Ansible controller. Just these are the words that I'll probably be using throughout this tutorial and other people may use when talking about Ansible. So how does Ansible even work? Well, a network protocol called Secure Shell, or SSH, is used to encrypt communications between machines. All data transmitted between two machines are secure and shielded from prying eyes because it creates an encrypted connection between the Ansible controller, which is the machine that is running Ansible, and the remote computer and/or machine. SSH additionally refers to authentication, which verifies the legitimacy of remote machines and guarantees that you are connecting to the right one. Remember when I said that Ansible is agentless? As a recap, agentless means only one machine needs to be running Ansible, and the other machines that the Ansible controller interacts with do not require Ansible to be installed. Well, through the SSH connection, the Secure Shell connection, Ansible communicates with other computers. When you run a playbook or a command in Ansible, it establishes an SSH connection with the target machine and issues commands to the remote machine to carry out the desired action. The IP address or host name of the machine, as well as the username and password or SSH key that you will use to authenticate the connection, are required when configuring Ansible to work with a remote machine. These credentials will be used by Ansible to create an SSH connection to the remote machine. Now, the remote machine is also sometimes referred to as the managed node or the remote system. Just keep those terms in mind. Setting up Ansible on your machine. Visit the documentation website in order to install Ansible to the machine you want to make your Ansible controller, aka the controller node. As for the controller node, the computer that you're running Ansible from, that is, it's not required to take the operating system of the controller node into consideration when you're making changes to managed nodes, the machines you wish to make the changes on, those remote machines that we were talking about before. Ansible can operate on a range of different operating systems and may be used to manage managed nodes running a diverse set of operating systems as well. But when designing systems, sometimes we want to have a bit more continuity and we want to limit the variation, so it would be ideal for your managed nodes to have similar operating systems, if not the same. The operating system of the machines we wish to target will determine how we go about structuring things later on. For this tutorial, all of our machines, the controller node and the manage nodes, will be using a Red Hat-based Linux distribution operating system. Also, there are possibilities and instances where you may want to make changes to the controller node itself by using Ansible, and this is possible. So in summary, just to keep things a bit less convoluted, because I think I probably confused you there just a bit, you more so have to know about the operating system of the machine you want to make changes to with Ansible. This could be the machine that you're running Ansible on, or remote machines elsewhere. So you just want to know the operating system of the machine you want to make changes to, and then tailor those Ansible playbooks and commands to those specific machines. Because sometimes, depending on the operating system of a machine, some software that we may install have different naming conventions and maybe dependencies and additional software. The simplest way to install Ansible onto your machine that you want to have as your Ansible controller node is to install Python on that machine and use Python 3 or pip3 command to install Ansible. Here's an example starting with installing Python onto a Red Hat-based Linux distribution, then using Python to install Ansible. I want to point something out. When you're making system changes and updates, you will be using root privileges. This is admin access to run specific commands on your Linux machine. You'll be doing this with the sudo command following the respective update command for your Linux distribution. Again, I want to mention this. We're using Red Hat Linux-based distributions for all machines in this tutorial. This assumes the following: that your machine is using a Red Hat Linux-based distribution and it has yum as its package management tool. We're going to run the following commands. 1. Sudo yum install Python 3. 2. Once the installation is complete, verify that Python 3 was installed correctly by using the following command: Python 3 --version. This will show a version of Python that's downloaded to our machine, thus verifying that we actually have installed Python. So now that we've installed Python, let's use Python's pip. Pip is a package management system for Python, and it's used to install and manage software packages written in Python. It is included by default with the Python binaries that we installed onto our system. So we're going to run this command: Python 3 -m pip install --user Ansible in lowercase. We will confirm if Ansible is installed by using the following Ansible version command: Ansible --version. Command code anatomy: sudo yum install Python. The sudo yum install Python 3 command installs Python 3 package from the default software repository on your system. Sudo is a command that allows you to run a command as the super user, also known as the root user. This is necessary because the installation process involves modifying system files, which requires super user privileges. Yum is the default package manager for Red Hat-based Linux systems, such as Red Hat Enterprise Linux and CentOS. It is used to install, update, and remove packages on these systems. Install is an option that tells Yum to install a package. Python 3 is the name of the package that we wish to install. This package contains the Python 3 interpreter, the standard library, and other tools that are needed to run Python 3 programs on your system. Command code anatomy: Python 3 -m pip install --user Ansible. The Python 3 -m pip install --user Ansible command installs the Ansible package for the Python 3 interpreter. Python 3 is the command that runs the Python 3 interpreter. -m is a flag that tells the interpreter to run a module as a script. In this case, the pip module is being ran as a script, which allows you to install Python packages. Install is an option that tells pip to install a package. --user is a flag that tells pip to install the package for the current user only, rather than for all users on the system. This means that the package will be installed on the user's home directory rather than the system-wide location, but you can choose about doing this for all users if you want to. Ansible is the name of the package that we want to install. Ansible is a configuration management and orchestration tool that is used to automate the deployment and management of applications and infrastructure. Where should you code? You can use any sort of text editor, notepad, integrated developer environment, or even access Linux Vim or Nano to make your files. If you're on a Linux machine, you should look up how to create a file in Linux command line interface. So I made my code in Visual Studio, then I copy it with my keyboard and mouse, the code itself that is, and then I go into my Linux machine, type in VI and the file I would like to create, along with the file extension. So something like this. When you're done, click the escape key on the keyboard and then navigate out by using the proper Vim commands. So you can use WQ to save and quit, or if you make a mistake and you don't want to save it, you can just use Q. But really, look up Vim commands. This isn't a Vim tutorial, so I'm sure you can find some quick Vim guides. I can leave some in the description of this video. Vim is very useful just to quickly change things, or if you want to, just code in Vim in general. Basic concepts. Modules. In Ansible, a module is a piece of code that performs a specified task on a managed node. Ansible offers a huge variety of built-in modules that may be used to automate a wide range of operations, such as installing software, transferring data, and updating system settings. Here are a few examples of built-in Ansible modules. The yum module may be used to manage packages on Red Hat-based Linux systems. You can use the yum module to install, update, uninstall packages if you want to. If you were paying attention, we used yum before to install Python on our Red Hat-based Linux machine. The copy module may be used to copy files from the Ansible control machine to manage nodes. You can use the copy module to transfer configuration files, scripts, or any sort of file. The service module can be used to handle system services on a managed node. You can use the service module to start, stop, or restart a service, or even to check the status of a service. These are just a few examples of the numerous built-in modules available in Ansible. You may use these modules to automate a wide range of processes on your managed nodes, and to make your infrastructure more efficient and consistent. In addition to built-in modules, Ansible allows you to construct your own custom modules if you want, and you can do this in any coding language. I've seen people mostly do this in Python. And your custom modules can be used in the same way as built-in Ansible modules. In this tutorial, we will not be making a custom module that's a bit more advanced. Maybe in a future tutorial, I'll probably focus on that. Inventory files. In Ansible, an inventory file is a list of managed nodes, machines and computers alike that Ansible is set to work on. It is a plain text file that specifies the host names or IP addresses of the managed nodes, as well as any pertinent information about those nodes. Command code anatomy. Simple inventory file. In this example, the inventory file defines 6 managed nodes, node 1 through node 6. The nodes are grouped into 3 groups: all, web servers, and database. The all group comprises all managed nodes, while the other groups are used to classify nodes into logical categories. And this is pretty much the syntax of the grouping. The top set of node 1 and node 2, as you can see, there are no brackets there. That has a name between the brackets, but essentially all refers to every single one of these nodes. But as you can see for nodes 3 and 4, it says web servers, and this is essentially the web server nodes. So essentially this is the syntax of the inventory file. If you want to group things into logical categories, you put brackets, and in between those brackets you have the name of the group. So as you can see, web servers, it's in between brackets, and under the web servers group, there are 2 machines, node 3 and node 4, along with their IP address. In addition to host names or IP addresses of the managed nodes, the inventory file can also include other information about the nodes, such as the connection details and the variables to use when executing scripts on those nodes. Inventory files are a crucial aspect of Ansible since they specify the managed nodes that Ansible will be working on. You may utilize inventory files to categorize manage nodes by environment, function, or any other criteria that is important to your infrastructure. Ad-Hoc Commands. Now, earlier in this tutorial, I mentioned Ad-Hoc Commands. Ad-Hoc is Latin for this or as needed. This is a single command that is typically used to check something quickly or to perform a quick task. For the sake of convenience, you essentially perform this command as needed, hence why it's called an ad hoc command. Command code anatomy. Run an ad hoc command. Here's an example of an ad hoc command that uses the yum module to install Apache HTTP server package on the web servers group of managed nodes. This command consists of several parts. Ansible, the command to run Ansible in the Linux command line interface. Web servers, the group of managed nodes on which the command should be ran against. -m. -m indicates the module for a command. In this case, we're pointing m to yum, so it's specifying that we're going to use the yum module. And remember, yum is used to manage packages on Red Hat-based Linux systems. -a space name equals HTTP, space state equals present. The arguments to pass to the module. In this case, the name argument specifies the name of the package to install. Here we're installing HTTPD, which is what Apache is called only for Red Hat-based Linux distributions. The state argument is set to the value of present. Present means that we are installing software to our control node. Note, HTTPD is also known as Apache. It is a web server software. Now, more on that shortly on what a web server software means, but I want to reiterate this again. Depending on the operating system you have, the naming convention of the certain softwares when it comes to Ansible installing those things for you will be different. Because on Debian, HTTPD or Apache, that isn't the same name. When you're using Ansible to install something on a Debian operating system, it's called Apache 2 when you're trying to go find Apache to install. And for our Red Hat Linux-based systems, it's simply called HTTPD. So again, we're going to touch on that later on in the tutorial, but I just wanted to point that out a bit sooner so you get that in your head. So in summary, the name of the software that we're trying to download is sometime contingent on the operating system that we have. This command will connect to the web servers group of managed nodes and use the yum module to install Apache HTTP server package. If the package is already installed, it will not be installed again. Playbooks. An Ansible playbook is a script that describes a set of tasks to be ran on one or more managed machines and/or nodes. It is written in YAML and consists of a list of jobs or tasks that are done in sequence. Let's start by looking at the anatomy of an Ansible playbook. When we start an Ansible playbook, the file extension is usually .yml or .yaml. You can name it either extension. We must include 3 hyphen minuses at the beginning of the playbook. This indicates the start of a YAML document. It is required in every Ansible playbook that we do this. Start out with the 3 hyphen minuses at the top of the playbook. Make sure there's no space after the last hyphen minus. And then under that, we will proceed to make our code. Indentation is important in YAML because it defines the structure of the document. Tasks and directives should be indented using 2 spaces, and the contents of tasks should be indented using 4 spaces. Note, in Ansible, a directive is a keyword that specifies a particular action or behavior. Let's look at the common directives that you will see in a majority of Ansible playbooks. The host directive specifies the managed nodes on which the playbook should be ran against. It can be used to specify a group of nodes defined in the inventory file or to specify an individual node by hostname or IP address. The become directive tells Ansible to use privilege escalation via sudo. to execute the tasks in the playbook. This is often necessary when performing tasks that require root privileges, like updating critical machine software. The task directive specifies the tasks to be executed in the playbook. It contains a list of tasks, each of which defines an action to be performed by the managed nodes. Command Code Anatomy. Ansible Playbook Directives. Here is an example of an Ansible playbook that uses these directives. This playbook example uses the following directives. Hosts. Specifies the managed nodes on which the playbook should be ran against. Become. Become tells Ansible to use privilege escalation via sudo to execute tasks in the playbook. Tasks. Tasks specify the tasks to be executed in the playbook. This playbook also uses the following modules. Yum. Yum installs, updates, or removes packages on managed nodes that are running Red Hat-based operating systems, so like CentOS, Fedora, Red Hat, Enterprise Linux, and even Amazon Linux itself, which we will be using later on. Amazon Linux, I think we're going to stick to in this tutorial. Service. Service controls the state of system services on managed nodes. Service can be used to start, stop, restart, or enable services. This playbook runs on the web servers group of managed machines in our storage file and uses privilege escalation to execute the tasks. The tasks themselves use various Ansible modules to install, start, and enable the Apache HTTP server. Command Code Anatomy. To run an Ansible playbook. To run an Ansible playbook from the command line, you use the following command. Ansible-playbook space the name of the YAML file space -I space the name of the inventory file. So in this case, the name of the YAML file is main.yml and the name of the inventory file is inventory.ini. So just these two things we're working with. You can name it whatever you want, but I'm just calling it this for the purpose of the tutorial. This command tells Ansible to run the playbook contained in the main YAML file using the inventory specified in the inventory.ini file. The inventory specifies the managed nodes, also known as machines, that the playbook should be ran against, and can include a variety of information about the nodes such as their host names, IP addresses, and group membership. Industry examples for Ansible playbooks. Creating and maintaining a web server. You might write a playbook one day that installs a web server on your computer, or that sets up a new user account on a server. Then you can run the playbook using Ansible, and it will perform the tasks for you automatically. We will be hosting a web server on a machine later in this tutorial. However, if you don't know what a web server is, essentially, a web server is a piece of software that runs on a computer. This software is designed to host websites and serve them to users over the internet. When you visit a website, your web browser sends a request to a computer that has web server software that hosts contents of a website. This computer is called the host machine. And the computer that's making the request, you typing in your browser that is called the client machine. So your browser makes a request to the host machine, and then the host machine listens to that request and sends the contents of that website that's on the host machine back to your browser. And now you can visit the website. The host machine that has the web server on it will consist of the following. A server operating system. This is the software that runs on the host machine that provides the necessary tools and services for hosting the websites. A service, for example, would be the web server software that's on that host machine that helps us serve the website's contents. Here are some examples of server operating systems. Microsoft Windows Server, Linux, so Ubuntu, CentOS, Red Hat, Enterprise Linux, Fedora, and much more. Mac OS Server, Unix, like Solaris, AIX, etc. The web server software. Now, this is the software that's on the host machine that listens to requests from the web browsers of client machines and sends back the appropriate content. Some common web server software programs include Apache, Nginx, and Microsoft IIS. And in this tutorial, we're going to be focusing on Apache. Website content. This is the content of the website itself, such as an HTML file, images, and other assets. Domain name. This is the human-readable name that is associated with the web server's IP address. When you type a domain into your web browser, it is translated into the IP address of the web server that hosts the website. Localhost changes. Ad-Hoc and Playbook. In Ansible, localhost refers to the machine that Ansible is operating on, the controller node or the Ansible controller. We mentioned this before. This is often the computer that you're running the Ansible-playbook or the Ad-Hoc command from. You can make modifications to the localhost by running the Ansible-playbook or Ad-Hoc commands on the machine itself. So you're basically going to be targeting the machine, your controller node, which is called the localhost. Hopefully that wasn't too redundant, but I want you guys to get the idea. Command code anatomy, altering localhost, playbook, and ad-hoc examples. For example, to install Python on the localhost, you might use a playbook like this. You can use an ad-hoc command to install Python on the localhost. For example, for both playbook and ad-hoc examples, the yum module is used to install the Python package onto the localhost. The state parameter is used to specify the desired state of a resource. The name of the state is dependent on the kind of package manager we are using. In this case, we are using the yum module. Some possible values for the state parameter in the yum module are the following. Present. Present installs the package if it's not already installed. It does nothing if the package is already installed. Latest. Latest installs the latest version of a package. If the package is already installed, update it to the latest version. Absent. Absent removes the package if it is installed, and it does nothing if the package is not installed. So this yum module is just a package management tool, like I mentioned before. So hopefully this reiteration helps you understand what yum is. And remember, yum is only for Red Hat-based Linux distributions like Fedora, CentOS, and even Amazon Linux. So just remember. Variables. In Ansible, variables are values that can be used in playbook tasks and templates. They allow you to reuse values and make your playbook more flexible and easier to maintain. Let's take a moment to make a learning connection to a future part of this tutorial. So towards the end of this tutorial, we will be making a web server. Remember, a web server is a piece of software that runs on a machine and listens to requests made by other machines. When this request is made, the web server sends website content information present on the web server machine to the machine making the request. Note, the machine making the request is called the client machine, and the machine listening and responding to this request is called the host machine. It is the host machine that is running the web server software, which, again, is just a piece of software on the machine that is listening and forwarding a website content. The client machine is what makes the request from a browser. One such web server software that we will be using is Apache. Well, in order to do this, the web server needs to have certain network ports open. One such networking port that handles requests made to websites is port 80. Port 80 handles HTTP requests. So we will need to turn on port 80 on our machine. Here is an example using a variable set to 80 in an Ansible playbook. This playbook installs the Apache HTTP server on a managed node in the web servers group using the yum module. It then starts the HTTP server and ensures that it is enabled to start on boot. The HTTP port variable is used to specify the port number for the HTTP server. This will execute the playbook on all managed nodes in the web servers group and configure the Apache HTTP server according to the tasks in the playbook. Variables can also be in separate files called variable files. Variable files are useful for storing sensitive information, such as passwords, API keys, or for storing values that are used across multiple playbooks. Command code anatomy. Variable file. Here is an example of a variable file. It's pretty much like a dictionary, right? It comes with a key-value pair. The key is the variable name, and the value is what comes after the colon. Note, Notice how in our example under the vars section, there is no longer a variable for http_port. Well, this is because we already included it in our vars.yml file. You do not need to define http_port variable again in the vars section if it's already defined in the vars.yml file that is included in the vars_files directive. The vars_files directive loads variables and their values from a separate file, a separate YAML file, and allows you to use those variables in your playbook. If you have already defined the http_port or any other variable for that matter in the vars.yml file, you can simply use the variable in your playbook tasks without defining it again in the vars section. You may ask the question, how come the Ansible SSH private key file variable is not referenced in the main.yml? When is the variable actually used throughout the playbook? The Ansible SSH private key file variable isn't directly throughout the playbook, and really, it's outside of the vars directive. It's needed to configure the SSH connection that is used to connect to nodes that we specified in this storage file. It's not a variable that is utilized in the task directive of the playbook, but rather a connection option that is used to indicate the location of an SSH private key file. When you want to connect with machines that use SSH connection protocol, you need permission keys so Ansible can execute the changes you wish to see on the machine you are connecting to. In Ansible, the double curly brace is used to enclose a variable. When the playbook is ran, Ansible will replace the variable with its value. In the example provided, the key variable is used to specify the path to an SSH private key file. The value of the key variable is expected to be a string that contains the path to the key file. The vars_files directive in the playbook includes the details of the key so that the Ansible tool can read the vars.yml file and set the key details to the Ansible SSH private key variable. In relation to the overall playbook, the main.yml playbook contains the become directive to execute tasks with root privileges. The vars files directive loads variables from the vars YAML file. Main.yml also includes the vars section to define the http_port and the Ansible_SSH_private_key_file variables, and the task section to describe the tasks to perform on the managed nodes. The steps in this playbook will install the Apache HTTP server, start the HTTP server, and ensure that it is enabled to start on boot. The HTTP_port variable is used to define the port number for the HTTP server, and the Ansible SSH private key file variable is used to indicate the path to an SSH private key file. Skill checkpoint. The ping module is a simple module that tests connectivity to the managed nodes. It is a good way to test that Ansible is able to connect to and execute commands on the managed nodes. Assignment 1. Create an ad-hoc command that pings the local host. Assignment 2. Create an Ansible-playbook that pings the local host. Name the playbook ping.yml or .yml. Assignment 1. Create an ad-hoc command that pings the local host. Answer: Ansible localhost -m ping. Assignment 2. Create an Ansible playbook that pings the local host. Name the playbook ping.yml or .yml. Answer: to run the playbook, run this command, Ansible-playbook ping.yml. This was probably a bit confusing when it came to writing the playbook, right? Well, in Ansible, the ping module is a basic module that does not need any other parameters. It is used to verify connectivity to them. When you specify the ping module in an Ansible task, Ansible will run the ping module on the managed nodes indicated in the playbook. In this scenario, the playbook indicates that the ping module should be performed performed on the local task, on the local host. The ping module does not require any more arguments, hence it does not need to be coupled with any other parameters. Simply supplying the ping module in the task is sufficient to execute the ping module on the managed nodes. So now onto our project, let's make an Apache web server machine. I'm going to be using AWS Amazon Web Services for this particular project, and we're going to be using an EC2 instance to actually make this web server. But you can use any other machine. Just try to follow along. Remember, we're using a distribution of Linux that uses Yum as its package manager. So I'm just going to create an EC2 instance on AWS. Now, you don't have to do this unless you want to do the same thing, so long as the machine you're working on is going to have Yum, Y-U-M, as its package management tool. So this could be CentOS, this could be Red Hat Enterprise Linux, this could be Fedora, this could just be a whole host of other Yum-based machines. So you don't have to follow this, just make sure the machine you're going to be following the tutorial on and running Ansible has Yum, Y-U-M, as its package management tool, or is some sort of Red Hat Linux distribution. So I'm going to go ahead and make the server. If you want to copy me and use AWS as well, then you can follow along. But this step is not necessary. So let's get started. I want to create my EC2 instance. I want to name it, call it web server. We're going to pick the Amazon image. I'm going to create a new key pair. So this is necessary if we're going to access the EC2 instance remotely. So if we want to remotely access the machine, I'll show this later, we're going to need this key pair. My new key. We're going to call this my new key, and we're going to create the key pair. I'm going to save my new key to my desktop. Anyway, let's continue. So we're going to create a security group. Now, this gets into some networking stuff, but if we want to allow SSH communication into the instance, then on Amazon, on AWS, we have to allow something to go through the firewall. So right now, I'm in AWS console. What I'm doing is that I'm editing ports 80, 443, and port 22. Port 80 and 443 are responsible for HTTP and HTTPS protocols respectively, whereas port 22 is responsible for maintaining SSH connection. I'm actually making these edits to the VPC. VPC stands for Virtual Private Cloud. This is a logically isolated area which allows us to create a virtual network with its own rules. And with this kind of editing of ports, I'm making a security group rule that will be attached to the EC2 instance. That is the machine that is going to exist in this virtual network, this virtual cloud, private cloud, or whatever you want to call it. These rules are going to attach to that machine to allow us to open those particular ports. But I'm also going to manually open those ports on the EC2 instance as well later on, because I need to have ports 80 and 443, at least 80, open for the web server to actually work. So I saved the AWS SSH key to my desktop. I'm going into my terminal and I'm going to change the directory to my desktop. I made sure to apply the necessary chmod changes that will allow me to execute the SSH key permission file in order to access my EC2 instance, that virtual machine that exists in that virtual private cloud on AWS. Remember, this isn't an AWS tutorial, so this section is just me explaining how I set things up so I can create a machine with a Red Hat-based Linux operating system. So you can just now follow from here. So now we're going to make a playbook for creating a web server. So if you look here, we're going to be targeting the local host. First, we're going to use Vim to create a file called webserver.yml. You can name it whatever you want. I already did that, so you're going to see the code already written out, but I want to walk you through the playbook. Host, localhost. So for the host section of the playbook, we're going to make it the local host. This is because the goal is to make the web server on the Ansible controller itself. So we're going to configure the playbook to target itself. or the machine that it's running on, which is the localhost. Yum. We're going to use Yum. Yum is our package management tool. A package management tool allows us to uninstall, install, and update software on our machine. Yum is used by Red Hat-based distributions. We're using Yum to install Apache. Remember, Apache is named differently for different distributions of Linux. So for Red Hat-based distributions, it will be called HTTPD. Next, we're going to create an HTML file. This HTML file is necessary for the web server. Apache has one in stock, but I want to just get it out of the way and make our own example. It will say hello world in the text file. I'll go back to it later and add the necessary HTML document tags such as the header and paragraph tags if needed. This file will be saved in the var www HTML index.html path, and this path is where Apache will store web server content, such as the web page, and serve the HTML content to the client machine. I'll navigate to the file directory later and make the edit I was talking about. Next, in the playbook, we're going to start Apache, then enable it with specific changes we made. This change being the HTML that we created in the var www HTML directory. So now it comes to turning on the necessary ports for the web server, Apache, to actually listen to certain protocols, so that being 80 and 443, in order to actually serve those to the client machine that's making the request. Now, it's going to be a bit weird because we're actually going to be making the request from the localhost itself by just grepping the localhost IP address, but this is more so just to show you the process to see if the web server is up and running. But anyway, we're going to use the Ansible built-in IP tables module to turn on specific ports on the machine itself. So I can break down the Ansible built-in IP tables task. So this task will use IP tables module provided by Ansible to configure the localhost firewall. The chain part input, this specifies the firewall chain that the rule will be applied to. In this case, the input chain. The input chain is responsible for incoming traffic that is destined for the local machine. So we're telling IP tables, hey, we're going to be editing the input traffic or the traffic that is going to be coming towards the machine. We want to turn on specific ports so the machine can listen to it, and therefore the web server can also listen to it and serve web server content. Protocol, TCP. This specifies the network protocol to which the rule will be applied to. This is TCP. Destination port, 80. This specifies the destination port number for incoming traffic, in this case port 80. Since HTTP uses port 80, this rule will allow HTTP traffic. State, new. This specifies that the rule will only apply to incoming connections as opposed to already established connections or ones that are being closed. Jump, accept. This specifies the action to take when the criteria of the rule is met. In this case, the action is to accept the incoming traffic. Comment, open HTTP port 80. This is just a comment associated with the rule, which can help with understanding the purpose of the rule when reviewing the firewall configuration later. In this case, the comment indicates that the rule is for opening port 80 for HTTP traffic. Next, we're going to run the Ansible-playbook. We don't need to supply an inventory file. When we don't do this, it defaults to running against the local host. So now I have the ports on and Apache installed with the help of Ansible. And you can see how easy it is to do all of this once the playbook was configured. I'm going to navigate to the var file and touch the HTML file in the HTML folder. I want to see if the file says hello world as it was written out in the Ansible inline file text. Before I mentioned how I was going to update the file with proper HTML formatting, so I did that here using Vim. Then I entered the necessary Vim commands to save and quit the file. Now I'm going to run a series of commands to check if the web server is on. So I can do this by using the curl curl command on the localhost itself. If Apache is on and configured properly, it should show the contents of the index.html file. As you can see, it does give me a response as it shows the HTML file content. We can do additional things to check if Apache is working. This command, sudo lsof-i80443, is used to show a list of open connections on ports 80 and 443, which are the default ports for HTTP and HTTPS protocols respectively. The lsof command stands for list of open files, and it's used to display information about files that are currently open by processes on a Unix-based operating system. The -i option is used to display network connections, and the 80443 argument specifies the ports for which to display connections. The sudo command is used to execute the command itself with escalated privileges, as listing open network connections typically requires root access. The command sudo netstat-tlnp, and then you have the pipe grep httpd, is used to list all network connections that are currently active on the local machine and are using TCP protocol, and filter out the output to show those connections that are associated with the httpd process. Here is what each part of the command does, and we're almost at the end, so I guess I'll just run through it quickly. Sudo is used to execute the command with escalated privileges, as listing active network connections typically requires root access. The netstat command displays active network connections, network statistics, and network interfaces on a Unix-based operating system. -tlnp are options to netstat that specifies the type of connections to display. -t displays only TCP connections. -l displays only listening ports. -n displays port numbers instead of the service names. -p shows the process ID, or the PID, and the name that is associated with each connection. So this will be helpful for showing if it's associated with HTTPD. The line, or the pipe, is an operator that allows the output of netstat command to pass it to the grep command, and grep is a command that searches for a specific pattern in text input. So I put HTTPD here, and that is the pattern it's going to search for. So in this case, the command will display only the active network connections that are associated with the HTTPD process.